All systems were go with the operations of the Mars probe until that asteroid smashed into the spacecraft. Mission aborted. The space probe and its rover crashed onto the Martian surface. The challenge now is to salvage the mission.
I have wheels, a computer for a brain, and a battery.
Welcome to Nomad Crash Landing. Juan Benito is the game's creator and developer.
The rover has some internal resources, and you've got to manage those. So you've got so much power, just like a real rover has, and so much RAM for your program to fit in. So part of the play experience is optimizing your program so it fits in the memory and won't use up all the rover's battery when you run it.
The red and blue lines look like my axes, so the green line must be the line I'm plotting.
The game is not easy, but Benito, who's designed dozens of computer games and co-founded several game design studios, says that's the point.
And so you're using a programming interface here, using these simple blocks, but you're not just making a program, you're actually solving some math here. If you notice, these are all arithmetic operators here. You've got some variables there. Y is where you plug your graph in. And when you do that, it actually displays the graph. So the game player's task is to make that green line match up with those treads that they're going off in this direction. And when they do that, as in this case, they'll now have a target to go to, but to reach that target, they've got to count the slope of that line. And then they use the number of blocks that form that slope to determine the movement for the rover to then follow that line. So it's really, we're trying to make a very tight coupling between programming and the mathematics.
So now I know I need to go up 1 and over 2 to get to the next point on the line.
Nomad Crash Landing is one of the next generation of video games.
Another incredibly wide diversity that games have now are the kinds of things that games are aiming to do. So not just about turning your brain off and having a shoot 'em up experience, but to learn, to teach people things, and not just practical skills, because there's certainly that, but also just sort of empathetic skills, what we would normally think of soft skills, can be taught through games. I think that's a really, really interesting development that we've seen over the last 10 years in particular. Gamification is maybe a term that you have heard to call it, and that's because games are very useful in many different ways for things beyond just entertainment.
To achieve those lofty goals, video games are designed to be accessible across a wide variety of web browsers and to be played on multiple devices. Games can now be streamed while playing. There's no need to download the game. And games boast 3D graphics, full sound effects, and music.
It's just because you can really create something from nothing. You start with a blank sheet or a blank, computer page, and you write things that make the computer do what you want it to do. That's very empowering.
But to make it all work depends on what programmer Martin Duparc is doing right now. Writing code. Each line controls one event on the screen.
You have to be prepared for anything. You don't know what the player will do, right? So you have to anticipate the actions and prepare the computer, for those actions. So in case it clicks, you need to do one thing. If it doesn't click, what happens next?
I can display.
There's a code or language for what is called the front end of the game. It's what the user sees on the screen.
I can see where I can drive. I can connect blocks.
But there's also a separate code or language for what is called the back end of the game. It controls where the user is and what the user is doing, as well as the score, how the player is interacting with the game, and if the game is performing correctly. The challenge for a game designer and programmer lies not only in anticipating what the user could do, but also in typing the code correctly. One wrong numeral, or letter, or symbol, and the game won't run.
It never ends because everybody is different. People play, for different reasons, which is a challenge. That's why It's important to think of the ways people will play the game and how they will play it.
North Carolina is one of the leaders in this gaming revolution. There are roughly 40 game development companies across the state. It is one of the largest concentrations on the East Coast.
If you look a couple years ago, about 5-6 years ago, there was a big term like serious games. It was really out within the market. It was the big thing. They were utilizing technology. Hardware had caught up to it, so you could, use it within the workplace. But then a lot of C-level executives didn't want to have their employees play games, so they kind of stood back from it a little bit. But now the same people, C-level executives, are seeing their children playing games. They're seeing that by playing games, the cognitive response of their learning, and now they start to kind of connect the dots. Well, I can have my employees learn too by playing games. So then what you do is you take the game technology, whether it's a game engine for a 3D simulation or just gaming techniques that you might see for like an Angry Birds, but do the same thing to build an application to allow our corporate or employees to train a little differently.
So just what is powering this gaming revolution? Well, it's not just the technology. It's simply that we've all become comfortable with games.
Every game player is a scientist because a scientist builds a model of the world that they test through experiment. And every game player creates an internal model of how they think the game world works, and they test that through interacting with it through gameplay. And based on those results, much like a scientist would be faced with results, they determine whether that aligns to the model that they had internally generated.